Good morning friends. Today we are going to discuss about the telescope. Already we discussed about the simple microscope and compound microscope. Now what is the uses of microscope? First we are going to discuss about what is the difference between microscope and telescope. Microscope is used to obtain the image of very small, that means the minute object, and also this object is very close to the objective. Very close to the objective lens. So with help of a microscope, either the simple microscope or the compound microscope, we can obtain its magnified image. Clear this thing? Okay. While in telescope is used to observe the far object. The object at very large distance, also very large in size, that means the hug in size, like as the sun, planet, right, star. When we are observing this type of the object, like as the star, planet, sun, at the time the size of this object is very large. But due to the far distance of this type of the object, we can't obtain its image clearly. For that purpose, the telescope is used. In telescope, generally used to observe the far object, so its clear image and also the magnified image is obtained by the telescope. So here, the working of the microscope and telescope are inverse of each other. What is the object lens? In microscope, here it acts as an eyepiece, and what is the eyepiece for? Microscope, here it is act as an objective. So in short, in microscope, the objective is small in diameter and also the focal length compared to the eyepiece. That means the eyepiece is larger than the objective. While in telescope, the objective is larger in diameter and focal length compared to the eyepiece. Okay, first we discuss about that the basic concept, what is the telescope, and discuss the types of telescope used in general. Which type of the telescope we are generally used? First thing, what is the telescope? Name is the telescope. Tele, far distance, scope, to view, that means to observe. Therefore, the optical instrument used to observe the far object, that is known as the telescope. Again, the optical instrument used to observe the far object is known as the telescope. Now the types of telescope. Generally we are using the telescope to observe the far object like as the sun, star and planet. So this type of the telescope is known as the Astronomical Telescope. This telescope is, the purpose of this telescope is to observe the astro object. Therefore, the telescope is used to observe the far object like as the sun, the star, the planet, etc. Again, the telescope is used to observe the far object like as the sun, the star, the planet, etc. The final image obtained by this telescope is inverted and diminished. That means the small in size. Okay. But the object are spherical. Therefore, there is no effect on its image. Generally, we know that the sun, star, planet are in spherical shape. Therefore, its inverted image or the real image, there is no change. And due to that reason, the astronomical telescope is used. There is no effect take place in the image. In spite of the image formed by the astronomical telescope is inverted and diminished. Okay. Now next is the terrestrial telescope. Okay. In this telescope, there is an additional inverting pair of lens. Again, in this telescope, there is an additional pair of inverting lens, which makes the final image clear. Because already we discussed in astronomical telescope, the image format is inverted. to again invert this image, that means the react to obtain the react image, the one more pair of lens are used. So this telescope is known as the terrestrial telescope. Now, Galileo first used the pair of concave and convex lens in this telescope. So keep in mind here the objective question is asked. The additional pair of inverting lens used in blank telescope, so that is known as the terrestrial telescope. And who first used the additional pair of the concave and convex lens in telescope, so that is the Galileo. After that, the third type of the telescope, that is the reflecting telescope. Reflecting telescope, that means a concave mirror is used in this telescope in place of objective lens. Again, instead of the lens, here the mirror is used. Which mirror? Concave mirror is used in this telescope in place of objective. Such telescope is known as the reflecting telescope, because here the phenomena of reflection is used to form the final image in this type of the telescope. And this telescope is known as the Cassegrain telescope. That is known as Cassegrain telescope. So friends, these are the types of the telescope. Generally, the 1 marks objective question may be asked in board exam, also the Bootcamp, and also another competitive exam. Here, generally 3 types of the telescope: astronomical, terrestrial, and reflecting. Clear this thing? Okay. After that, we are going to discuss about that. Explain the construction of astronomical or the reflecting telescope with figure and obtain the equation of magnification. For that purpose, here we do the ray diagram of the astronomical telescope. So a ray diagram of astronomical telescope is shown in figure. It's shown in figure. Okay, in this telescope, the 2 convex lenses are placed in such a way that their principal axes are coincide. In this telescope, two convex lenses are placed in such a way that their principal axes are coincide. Now, how we do the block diagram or the ray diagram of astronomical telescope? For that purpose, here we consider there is the common axis. Now there is our objective. Now the object is at far distance, therefore the ray coming from the object are partially very close to the principal axis and also the parallel. And due to that reason, we consider this type of the partial ray. So this ray, after the reflection, so both reflected ray meet at this point. So there is the image of the object formed by the objective. So that is the objective. Now here the eyepiece, that is the small in size compared to the objective. So the final image is formed by the eyepiece is at infinite distance approximate. So final image is formed. So these rays are entered to the eye of a person. That is eyepiece. Now, this length is known as the FE, focal length of eyepiece, and that is known as the focal length of objective. Now, this BDS, ADS, here the angle subtended by the object and objective is alpha. There is also alpha. Now, angle subtended by the image near the eyepiece is beta. There is beta. Now, there is the height of an object. So, this angle is also subtended is beta. Now, this is the height of an image, that is h. Again, the ray diagram of astronomical telescope is shown in figure. So that is the A double dash, B double dash. Okay. Ray diagram of astronomical telescope is shown in the figure. In this telescope, the two convex lenses are placed in such a way that the principal axes are coincide with each other. Right? Okay. So after that, here the lens facing the object is known as the objective, and the lens near the eye is known as the eyepiece. The lens facing the objective or the object is known as objective, and a lens near the eye is known as eyepiece. Hear this thing? Okay. So now there is the definition of telescope, types of telescope, and there is the ray diagram of astronomical telescope. Okay, now just we discussed about the ray diagram of astronomical or the reflecting telescope. Here the two lenses are placed in such a way that their common axes are coincide. Here the lens near the object is known as the objective, and near the eye is known as the eyepiece. Here now the eyepiece has the diameter and focal length is more than the eyepiece. Here the diameter and focal length of the objective are greater than diameter and focal length of the eyepiece. Focal length of an eyepiece. Now, what's happened? When the telescope is focused for the far object, so the ray from the object are formed by the objective, and its rear inverted, and the small image AB is focused on second principle of the objective. Again, when a telescope is focused on a far object, the rays from object forms a real inverted and small image AB at second principal focus of objective. Of objective, which act as that means this image act as a virtual object for eyepiece. Again, the ray coming from the far object forms the real inverting and also the small image on second principal focus of the objective. This image acts as a virtual object for eyepiece. Right? Now, eyepiece can move to and fro to get the final image at certain distance. This final image is again the inverted and also the magnified image. While eyepiece can move to and fro to get the final inverted magnified image at certain distance. Now, in this telescope, the ray coming from the far object are affected by the objective. Therefore, this telescope is also known as the effective telescope. In this telescope, the rays from object are reflected by objective. So, it is also called reflecting telescope. Actually, there is the astronomical telescope, but here the ray coming from the far object are parallel. These rays are reflected by the objective lens. Therefore, that is known as also reflecting telescope. Now we are going to discuss about the magnification of a telescope. The angular magnification of a telescope is the ratio of the angle subtended by the image with the eyepiece, that means the beta, to the angle subtended by the object with either the objective or with the eye. Right? Therefore, the angular magnification M is equal to ratio of the angle subtended by image with eye to the angle subtended by object with objective or eye. Now, here the angle subtended by the image with the eye is beta, and here the angle subtended by the object with the object is alpha. So beta upon alpha is the magnification of a telescope, astronomical telescope. Now we have to substitute the value of beta and alpha. So how we substitute it? So for this way, so here we consider this angle is, this point is O, that is our O dash. So here we consider this triangle O dash BA, O dash BA. Or triangle O dash BA, tan beta. Tan beta of this, that means the H upon FE, H upon FE. And here for this triangle OBA and for triangle OBA, tan alpha is H upon OB, that means the FO, that means the H upon FO, H upon FO. But alpha and beta are very small. Therefore, we take tan alpha as alpha and tan beta as beta. So substitute in equation 1. In equation 1. Therefore, what's happened? F is equal to H upon Fe divided by H upon Fo. Therefore, Fo upon Fe is the magnification of a telescope. Magnification of a telescope. Now, from this equation, we can say that to increase the magnification of a telescope, the focal length of the objective is increases, or the focal length of eyepiece must be reduced. To increase the magnification, the focal length of objective is increases. Focal length of the objective increase, or reduce the focal length of eyepiece. Clear this? Okay. Now, here only the two sentences is there. Okay. Now, the distance between the two lenses, that means the FO plus FE, is known as the optical length of a telescope. Now, FO plus FE is an optical length of a telescope. So, the tube length of a telescope is L greater than or is equal to FO plus FE. FO plus FE. That is the tube length of a telescope. That means the distance between the two lenses is always greater than the sum of FO plus FE, or equal to the FO plus FE. So this is the astronomical telescope, its ray diagram and its construction, and also the magnification.